Hello everyone, welcome to my YouTube channel. This is gonna be the very first video of my channel, so at a time I'm both excited and a bit nervous. So today what I'd like to discuss about is a very common and popular problem that's name is maximum sub-array sum, and I'd like to solve this problem using a very popular algorithm named Kadane's algorithm. At first, let's see what this problem describes. It says, from a given integer array, find the maximum sum of the subarray, which is a contiguous part of the array. What does this thing means? This means that we are given an array. This is an integer array, but here both positive and negative integers are present. From this array, we will have to find out a sub array or simply part of the array which is contiguous, having the maximum sum. If we have a look at this array, here the maximum sum portion will be this one, 4 to this one. This is going to be the maximum subarray and its sum would be 6. Now we'd like to solve this problem using dynamic programming. Almost all of us know about dynamic programming things. Still, I'd like to focus on some basic point of this very approach. It says divide the problem into smaller sub-problems. That means this whole problem will be breaking it into similar sub-problems, and we'll solve each of those sub-problems. We'll be solving each of these sub-problems gradually, and using the solution of each sub-problem, we will use the solution of the previous sub-problem to the next one. Thus, we'll utilize this result by using memorization or caching. That means if every time we get the new result with the help of the previous one. So if you look at this array, what are we gonna do is at first we'll try to find out the sum at this very point. That means in this first integer, try to solve the problem here, try to find out the maximum sum here. After that we go to the next one, then gradually we solve and move forward. Thus what we do, we divided this whole thing is by each similar sub problems, then we solve it, and thus we gradually move forward. Thus we solve the problem using dynamic programming. Let's go to the algorithm. At first, what are we gonna do is we're gonna take a variable named current sum. What this current sum means, it means that we're gonna get the sum at each index of the array. Then we have the another variable which we will return finally. This will contain the maximum sum, that means our result. We will initialize this current sum at 0 and this maximum sum with the minimum possible value, say int min in for C++. Now what are we gonna do is we're gonna iterate over the array. For each element we are simply going to update the value of both current sum and max sum. The next line is pretty much important and most tricky part of this algorithm. What does it say? It says the current sum will be maximum between n and n plus the current sum. That means whenever we will be in a certain array element, we will compare that very element with the current sum plus that very element. This part is pretty much trickier, so we will have to concentrate on this line very much. This is the most important thing. After that, what we are going to do is we'll update the value of this maximum sum. That means if this current sum is greater than the maximum sum, so update maximum sum. And when we are done with the array, we will simply return the maximum sum. Now let's apply this algorithm with our given example array. At first we will be in our first integer, that says -2. Now we are gonna update the value of current sum and max sum. Let's see, here the current sum will be what? its initial value is 0, so the current sum will be the maximum of n. Here n is -2 and minus n plus current sum, that means -2. So here simply the current sum is -2. Now what will be the maximum sum? Simple, pretty much simple. We have initialized it with mean value and we just got our current sum, so we compared and -2 is greater, so the maximum sum now is -2. So we move forward to the next integer. Here we also update the value of current sum. The current element is 1 and we make an addition of 1 with -2. So definitely here 1 is larger, so current sum is 1, and 1 being greater than -2, the maximum here is also 1. Now we move forward to the next position, that is -3. Here uh, here the element is -3 and we are getting -3 plus 1. Here 1 is the previous current sum. Our current sum's value equals to -2. So here the maximum sum will be, the previous maximum sum was 1 and -2 is not greater than 1, so maximum sum remains as 1. We go to the next position and now the current sum becomes the maximum of 4, and 4 plus -2, that means 2, so the maximum is 4, and 4 being greater than 1, the maximum sum here is 4. Going to the next part, again -1, and the current sum will be -1, the maximum between -1 and -1 plus 4, that is uh, 3. So the maximum between -1 and 3 is 3. So the current sum is 3, but 3 is not greater than 4, so maximum remains 4. Going to the next element, and here current sum at this very point becomes 5 because the current element is 2 and our previous current sum is 3 and the current element is 2, so adding these two we get 5, and 5 being greater than 4, the maximum becomes 5. Now we are going to the next integer element, and here it is 1. So here in this position we calculate the current sum. Our previous current sum was 5 and adding the current element to this gives us 6, and 6 being greater than 5, our maximum sum becomes 6. After that we again got a negative value, so definitely current sum will get decreased. The current sum is now at now is 1, but the maximum keeps remaining 6. And for the last element also we got current sum 5, but 5 is not greater than 6, so our max sum returns 6, and simply our algorithm returns the maximum sum as 6. Now let's talk about the running time complexity of this very algorithm. Here we can see that our code runs for a single loop, and it is dependent on the value of n, so our running time complexity will be O of n. So we are solving this problem in linear time. And if we talk about the space complexity, here we haven't used any external data structure. What we have used are two variables which are constant. So we can simply say our space complexity here is constant. That means O of 1. Thus we can solve this maximum Subarray sum problem using Kadane's algorithm. Now I am going to show you guys the implementation of this very algorithm using C++. Here we have implemented the solution of maximum subarray sum with the help of Kadane's algorithm in C++. Let's submit this code and let's see what happens, what we get the result. So we got a success, and it says our runtime is faster than 22.10% of the previous submissions, and memory usage is better less than 53% other submissions. Thus we got the accepted answer. That's all for today. Thank you very much.